Thank you. I've seen many speakers in this conference, but not just here. I would say in every conference, in almost every country, to welcome the audience by saying something about the hosting city. So I'm supposed to say, I'm in Moscow, well, and you know it, and because I'm in Moscow, well, I have this wonderful red carpet here, so I'm addressing masses from the red square. Okay, well, thank you. No, it was an agreed joke because I couldn't resist. Anyway, let's talk about the purpose of this presentation. I have microservices, and I didn't know. Yes, I didn't know. The point of this presentation is not much technical, in the sense that the value that I hope to be able to deliver, to share with you, is essentially the value of design, the value of thought, the value of putting a few things, a few buzzwords, two buzzwords in particular, microservices and domain-driven design, bound together, because, well, my point is just demonstrating that there is a tight link that connects together these two things. What's going on? Okay, manually. It always works manually. Ever tried? Ever failed? No matter. Try again. Fail again, but fail better. This is the summary, okay, of the essence of software architecture and many other things in life. Failing better. But this sentence is not just a nice collection of words. There is a true history behind those words, and to figure out where these words come from, they have been written by a Nobel Prize winner for literature, Samuel Beckett. In a book, I think it was a theater piece called Worst Word Ho. Now, the title is a little bit, weird, Worst Word Ho, but actually Samuel Beckett, I think, was from Ireland or from the UK. There is common in the known to people the words, the sound that pilots of boats going on the Thames River say when they signal to others the direction they are taking. So eastward ho, westward ho. So it was worstward ho. So we're going for the worst. Failing, just failing better. Microservices, what is this? How many times, now, I think that every developer has run into a similar situation. You join a new team, and you find someone, usually the nice guy, well-dressed, maybe with a tie, that addresses you, well, in the team I was before, we used the microservices, and it was so successful, so we should really consider microservices regardless of the real thing you are expected to build and to do. So microservices beforehand, these days, seems to be a must when it comes to software design. But my reaction is, don't be silly, go to work, and then if you happen to have microservices, okay, you have a microservices architecture and you didn't know. Many times, things look different from what they are. And these two pictures attempt to show that, it's two guys running, and the guy in the back is trying to stop the guy in front of him, but from a TV, from a perspective, you only see something that could even be interpreted in a completely different way. The It's just a picture, but you see that what is in reality the foot of the runner, the front runner, looks like the stab in the hand. Or the other picture, more romantic, is it the guy just playing a saxophone, or is it dreaming of a beautiful woman in the back? So things not always are for what they look. And microservices, in my opinion, are not exactly what we often hear and read that they are. And the primary fundamental difference that I experience here is that there is a lot more architecture around microservices than technology. If you today Google for, I'm sorry, Bing or Google, it's up to you. I want to be politically correct. If you Bing or Google or Yandex or I don't know exactly what for microservices, chances are that you run into articles, blog posts, references, links that connect together ASP.NET Core, Docker, containers, and microservices. Not that the binding is out of place. It makes sense. Because at the end of the day, you still need some technology to arrange everything in software. So technology is important, but the real relevance of microservices is more architectural than technological. So it's correct to say that Docker, containers, and because of that, a specific piece of technology for building certain types of applications like ASP.NET Core can be helpful and can be highly and strictly related to microservices, but microservices are something at a higher, significantly higher level of abstraction. Again, microservices, what is this? What is this? What is relax? Definition. Most of the content in this slide reference a link from the URL you see there, Martin Fowler page, which is probably one of the oldest but still valid definitions for a microservice. And in summary, we can think, or maybe we should think of a microservice as a particular way of designing software applications, has suites of independently deployable services. And each service runs in a dedicated process, communicates through lightweight mechanisms, so different microservices establish connections and communicate through lightweight mechanisms. A microservice, so this independently deployable software service enjoys a simplified, possibly automated way of deployment. And again, this is the specific point where technologies like Docker and containers come into play. And microservices, because again, they are independent, standalone, independently deployable pieces of code, they offer decentralized control of languages and data. In other words, you can use any language, any framework, any software technology, even any hardware and software combination of technologies to host and deploy microservices, still sure that through those lightweight, mysterious, lightweight mechanisms, two microservices can communicate. So this is essentially the idea. In other words, I'm now challenging you to recognize in what I've just tried to say and summarize, you can easily recognize here concepts, things you studied, you heard other experts to advertise and to promote not that many years ago. In other words, we are talking about SOA just made simpler. Oh my God. SOA is the big thing, microservices, SOA just made simpler. Highway with gas stations. This is a nice way to think of services, SOA services. Your application is a link that ties together many stops along the way, and the link, the tie that connects together, the thread that connects together the various stations, the various software blocks along the way, is expressed according to SOA, service-oriented architecture, by specific protocols, bureaucratic soft protocols to some extent, WS, Web Services, -XXX, Federation, Security, and so forth. In summary, those protocols and the boxes that form together the entire application went under the name of SOA tenets. And SOA tenets are essentially 4. Boundaries are explicit. Tenet number 2, services are autonomous. Number 3, services share schema and contract, not classes. I just copied it verbatim. I don't know what it means. Tenet number 4, service compatibility is based upon policy. And again, I just copied the verbatim, and I don't know what it means. But I don't think I'm the only one having troubles with tenets number 3 and number 4. So SOA simplified essentially means taking care primarily of tenets number 1 and tenet number 2, which are the really important part of the story. Boundaries are explicit. It means essentially that the public interface through which a microservice exposes its functionality is contract-based, explicitly defined, to some extent immutable. Tenet number 2, services are autonomous. Each microservice is independently deployed. And because of that, it can be blissfully replaced with another service at any time, even based on a completely different hardware and software platform, as long as the contract, the boundaries, the tenet number 1 remains valid. This is the part that from SOA gets simplified and brings to the core, to the essence, to the heart of microservices. So we can rephrase the picture, rephrasing a picture, that's nice, to essentially identify blocks, black boxes of code and black boxes of functionality. And what this picture, what this slide tries to express is that each block is connected to other blocks or to internal parts of a box. So the black box here at the bottom has a green cylinder representing a local storage. But you see that there's a dashed arrow that connects another block directly to the storage. So in this case, there is a possible connection between two microservices that bypasses the public interface but goes straight and directly to the storage. Now, I'm not here to question whether this decision, this architectural decision is something you should or should not take. It's anyway definitely a possibility that you use a shared storage as a way for two independently deployed services to communicate. And the nice thing is that once you have built your entire system around independent blocks, black boxes of functionality that in some way are connected to each other, we have quite a few entry points into the system, because each of those black boxes reasonably have a URL or something public that can be called from the outside to pass or receive data to order, for example, some operations. And if we imagine a cage, yeah, exactly, a red carpet like this, all around those black boxes of code, we see that reasonably we have just a few arrows here and there, the union of connecting points that the various black boxes have, and we have here what looks like not the simple application, but an entire software system with a few entry points that is completely hidden from the details from users. They know users, corporate users or customers can only see the entry points, and the internal architecture is invisible, but every block there, every black box can be replaced and be at some point at any time implemented in a different way, even changing completely the underlying software and hardware technology. And in this case, a technology like that of containers, Docker, for example, that is just the concrete implementation of this principle. Because with Docker, just replacing those black boxes, a container with another container, regardless of the underlying operating system, the underlying machine, virtual machine, that is possible. So the two things, containers and the concept of microservices, definitely go together, but of the two, the architectural perspective of microservices is, in my humble opinion, the part that you should focus more to get the real big picture. Let's rephrase now the definition of a microservice, and let's try to go in a little bit more detail. A microservice is what? Is a vertical stack of logic and data. Data and logic can be accessed via web services, via URLs. Essentially, that is the favorite primary way. Everything. I mean, this morning, there was a talk about serverless Azure functions. But in the end, it's a web service. It's a URL that you have to call in order to receive some data or to pass input parameters to have some operations performed. Another talk that you may have attended this afternoon about machine learning. Yet again, if you have configured a machine learning Azure service, you again have a bunch of URLs to call, to pass data, have the neural networks or whatever it was in the back, produce some result, predicts some result, and pass those results back to you. Those are vertical stacks of logic and data. Logic, okay, fine, but data? It's an architectural decision that has to be made case by case, business case by business case, on a per business domain basis. You might decide that every or some microservices, some of those blocks need to have their own local storage, even when this means replicating data that is also maintained somewhere else by another service. Or you can have a shared microservice that only owns a block of data and exposes a URL interface for the data to be shared. It's an architectural decision. Replicating data is not a bad thing at all. It is a solution, it is a trick, it is an architectural aspect that could work sometimes. You have to evaluate that, but don't refuse that. Oh, because replication, oh, because duplication is bad. Not necessarily, or not anymore. Those vertical stacks of logic and data should be easy to package and easy to deploy. Now, not that if they are hard to package and hard to deploy, they don't work. Because, of course, they work much better if they are easy to package and easy to deploy. And to achieve exactly this goal, we can take advantage of some technologies and some products, from Visual Studio to Docker to certain technologies. And ASP.NET Core is one of those that could make far easier and faster, automated because of tools, this goal. But the fact that we are now reasoning, we are essentially splitting our overall global comprehensive system in a collection of vertical stacks of logic and data also simplifies parallelizing the development process, because those vertical stacks are now easy to assign to development teams. You can have multiple development teams to work in parallel. You know the famous quote from the book, the Fred Brooks book, The Mythical Man Month. There was a quote there that says that 9 women can never deliver, no chance can they deliver 1 baby in 1 month. So parallelizing when it comes to software is a dream, is a limit to try to reach, but not necessarily is something that mathematically happens. But anyway, splitting the entire system in terms of microservices well isolated and easy to package and deploy also helps parallelizing the development and assigning different teams different microservices. Of course, it works, the entire thing works well with containers, but for example, it poses some issues if you use a Visual Studio, or in general, even beyond Visual Studio, if you use, I would say, whatever, IDE of today. Because how can you share easily small pieces of code in between multiple independent projects? NuGet packages are one possibility, but as long as all the pieces are on the same, in this case, .NET platform. So the way in which you organize and do your integration tests in the context of a microservice architecture becomes a challenge, and unfortunately, there is no magic, not in this version of life on this planet. So microservices are a way to react to monolithic apps. When I started my career, some 25, 7, 8 years ago, writing software was so easy. You could identify the first ever line of code and the last ever line of code. All applications were start to finish running end to end. Like you read a book cover to cover, you could run an app end to end, line to line. And everything was happening in the same unique block. Monolithic applications. By the way, the MVC, Model View Controller pattern, that you have heard about, for sure. You may have studied that or heard that at university at first. That was the very first attempt, and it dates back to the 80s, okay? I was not even involved in computers at the time, so you can imagine how, old time it was. So the MVC was the first attempt to break up a typical monolith an application was into pieces that, although living in the context of the same process space, could be treated by the development team as independent entities. The model, the view, and then the controller to route commands in between the various views that were displayed to users and getting fresh data through changes made to the model. The vision that we have today is, okay, we have a monolithic system, we have a big application. Most of the time, it's a big backhand, reasonably, has many chances to be a huge web application. And the idea is we want to see this sliced vertically into segments that are independent, vertical stacks of logic and data. But yes, the overall architecture is probably well represented by the graphics on screen now. And if you look at that, what we really have, a collection of monolithic applications. So the point of microservices is it helps. It's divide et impera. Break it up in smaller pieces, treat each smaller piece independently, maybe assign that to a different team, coordinate the various teams together, and you have more chances to take the project home, rather than if you build everything as a single, huge, humongous project where the complexity of the various logical different pieces is bound together, multiplies, instead of being maybe just added. Because if you have a collection of monolithic applications, the complexity of each monolithic application just sums up to the complexity of module number 2, module number 3, module number 4. But if you put all those modules together within the same application, the complexity is exponential. Is the complexity of module 1 by the complexity of module 2 by the complexity of module 3, you have easily an exponential function that describes the complexity. You are likely to have a polynomial kind of complexity if you just break it up in smaller pieces. So yeah, I recognize that it sounds like, ironic or funny that we are moving from a monolith to a collection of monoliths. But the trick, the value, is just in a collection of. And more in detail, every module you can have, every segment you can have in a microservice-oriented architecture, every piece there is again, independent, whatever that means, is independent from the operating system perspective, is independent from the frameworks being used, from the versions of the same frameworks that might be using, from the language, from every aspect. So what I tried to summarize in the graphics that you see on screen now is that, for example, the first block is connected to the next and has its own data storage that is hidden from the others. You can see in the middle of the graphics 3 blocks that are sharing the same storage, and the final 2 blocks that are communicating through something, a long cylinder that represents a bus. So the way you make those, every pair, every group, every subset of monolithic components is business specific and depends on whatever you may already have, things like legacy code, dependencies on certain versions of certain products. You are in the position of being completely free of making the decision that works the best given the context. The word context. I titled this slide From Bounded Context to Microservice. And again, context. Context is a keyword, is a term that should ring a bell, an alarm bell in your minds. Because when you say context, you probably should be thinking of one particular pattern in domain-driven design. And in fact, now we are entering in the area of this presentation where I try to share the theoretical foundation for this overall architecture. And the theoretical foundation, how do we get there? How do we go to Rome? Every road may take to Rome. So there are many ways to solve the problem. But the only thing that is in common here regardless of the many ways you have to reach a final destination, is the destination itself. And our destination is this architecture. The theoretical foundation to get there is domain-driven design. Now, domain-driven design is a methodology for doing what exactly? For writing software? I would say no. I would say no, domain-driven design is not primarily about writing software, about writing the code that you compile through Visual Studio, IntelliJ, or this or that, whatever IDE. Code written in C#, in Java, in F# or whatever else. Domain-driven design is exactly what the name states it is. It's design driven by the domain. So it's about designing. It's about modeling a business domain. Modeling in which way? It's about creating a software model specifically apt, made to measure for the business domain. So it's about recognizing the context. It's about, if I quickly switch back here, it's about recognizing the vertical stacks of logic that we can identify as software architects in the business domain. We have to understand the business domain, and understanding means not just making an idea how about the processes and how they work, but it's not just about the processes, the business processes, the workflows that users of that company, of that system have to go through. But it's also about understanding how the software components behind the process should be ideally architected, deployed, and connected together. This is the overall software model driven by the needs of the domain and purely inspired by the characteristics of the domain. As software architects, we too often enter in a sort of a God mode. We loved, I'm like God, I feel God today. So, where do I start? I have an invoice. No, there is something on top of the invoice, on top of the invoice, on top. And you start from object. You start from cosmos. You start from universe. Probably, domain-driven design says, look, you don't need to start architecting your model from the first day of creation. You have to start exactly where not just the business domain begins, but where each segment that makes sense to recognize begins. So, domain-driven design says fundamentally that there are two parts, two steps, neatly distinct, in which you have to approach the development, the understanding first, and the development next of a system. There is something called strategic design and something called implementation. Now, if you take the book from Eric Evans, which still today is the first stop on the way to learn about this methodology, in that book, which was written some 10 years ago, over 10 years ago, and as far to my understanding, never updated, in that book you find that the implementation part is the first thing you learn, whereas strategic design is covered in the second half of the book. So if you read the book cover to cover, inevitably your understanding, your mental image of domain-driven design is, okay, I have to write code according to a certain collection of guidelines and patterns, and what I read in the second half is essentially the theoretical justification for those practices. So reading that book cover to cover in the natural order of pages takes you inevitably to privilege, to give priority to software development practices, things like a factory is much better than a constructor, or don't use primitive types at all, and a few other things like have a domain model that knows nothing about the database, about the storage, or have 4 layers of code ranging from presentation down to infrastructure, passing for 2 layers of business logic. Those things, those implementation guidelines make total, full sense, but they are poor without a deep understanding of the strategic design, which is the part that is most relevant as far as microservices are concerned. So strategic design is about 2 big primary patterns: ubiquitous language and bounded context. Now, the ubiquitous language in this context of microservices is the least relevant. It's crucial for the success of any software initiative, but in this context is the least relevant. In summary, ubiquitous language is about using throughout the project whatever communication you arrange, emails, face-to-face discussion, code, documents, using the language of the business. And the moment you start going through requirements, you start collecting requirements, and you start learning about the language being spoken in that business context, it usually happens that you at some point go through words or expressions that either are similar but are given different meanings by different people, or different people call the same thing, the same logical thing in different ways. You have conflicts, ambiguity. Every time you face ambiguity in your path to understanding the ubiquitous language of the business domain, every time you run into a conflict of this type, you have a signal, you have a notification that you are possibly crossing the boundary between 2 different bounded contexts. So you are on the edge of crossing the distance between 2 slices of functionality that are better treated independently. So you can probably cut there, vertically, the complexity of the monolith and split in 2 parts, in 2 vertical slices of logic and data, your application design. And the parts that are split in 2 are called, this is the terminology used in domain-driven design, bounded context. So, as you can see, the implementation part in this context, implementation part of domain-driven design is not relevant. Strategic design is the most relevant part, but limited to bounded context. So in other words, when you approach the building, the understanding, the building of a software model for a business domain, you start considering, because you are ignorant, you know nothing about that. So in the beginning, you see a single business domain. And the more you understand about it, the more you discover the ubiquitous language, the more you can identify that you are better cutting vertically the business domain into multiple business subdomains, and bounded context is just the term used to call those business subdomains. Each subdomain is independent from any other. So the business domain unique disappears, replaced by, in this sample slide, by 4 bounded contexts, which are in some way interconnected. How? Well, the interconnection depends on the specific tasks you expect every bounded context to perform. So in summary, if I have to give you a definition for a bounded context, I would say a bounded context has 3 main characteristics. Number 1, it has its own ubiquitous language. Number 2, it has an independent implementation. Number 3, it has an interface to connect to other contexts. So in other words, a bounded context is a standalone piece of software that has its own business language, that has its own independent, autonomous implementation, regardless of the language, regardless of the software platform and hardware platform as well, and as long as its connection to the outside world is ruled by an explicit contract. So the telnet number 1 and telnet number 2 of SOA are there. And and those first 2 telnets of SOA is what characterize microservices today. When we say a microservice is a microservice, it's a smaller, simpler kind of thing. It's a SOA simplified, it's SOA based on the first 2 telnets. And here we go. The telnets are easily identifiable in the definition of bounded context you find in any DDD, domain-driven design, documentation, book, source. Why having bounded context? And this could be reread as why having microservices. The primary reason is, as an architect, you feel you have evidence that you are facing multiple areas, multiple functional areas of the application you are overall building that are better treated separately. A symptom that guides you to suspect that a functional area is better treated separately, even at the cost of duplicating something, logic and or data, is when the same term means different things to different people, or when the same term is used to indicate different elements of the overall system. So when you find ambiguity, conflicts in your collected set of requirements, especially when you deal with large organizations or just one department in a larger organization, you have to play by the rule of that particular department, of that particular subset, and build a model, a software model that is optimized for that particular subset or subdomain. If you have only one subdomain, fine. Otherwise, break the overall model into multiple models and treat each model independently. And again, the symptom, the notification, the alarm that rings in your mind is when you find conflicts in words, when you don't understand, when you say, okay, I have 2 requirements, which one is true? They requirements that contradict each other. That is the clear symptom that you are probably on the brink of 2 functional areas that are better separated physically. Another scenario for having bounded context is when you have a dependency on an external subsystem. Here, an example, classic example, is when you have a gateway, you deal with gateways for payment or for weather information, and when you have a dependency on a legacy code. So the final 2 points of why having a bounded context and then why having microservices is a microservice, a wrapper around a microservice is a wrapper around an external subsystem you don't entirely control, or a piece of legacy code you don't want to control because, okay, it's there, it works, as long as it does and gives me back whatever I need, I don't want to touch it. And this is context map is another concept of domain-driven design that is tightly related to bounded context. If I go back to here, the ubiquitous language, the independent implementation of functionalities that fit into the subset of the domain that you identified, And then how can I have any pair of identified bounded contexts to communicate? What is the graph, the map that connects together the various microservices? It could be a one-to-one or one-to-many or even many-to-many kind of relationship. So, and the right graph depends on your understanding of the system. So here we go. Context map helps, once you have found in blue bounded context, the arrows depicted on the slide use DDD-specific relationships to empower the architect, in this particular case, the owner of the entire project, on how the various microservices, the various contexts fit together, and also, more importantly, the priorities between the teams involved in the development of each bounded context. Now, you see that there are some arrows connecting a couple of blocks with a U and a D letter close to the edges of the arrow. So, for example, you have the central big blue box that you can imagine that to be maybe a web API, maybe a service, or just a stupidly simple class library, a .NET DLL, in the context of a regular, standard, canonical web ASP.NET application. The part that contains accounting logic, business rules, shipping logic, payment logic, that particular part is connected to the front end, where you also have the shopping cart, the application logic, the process I'm simulating here an e-commerce system, by a UD kind of relationship. U indicates that the bounded context the U refers to has to be considered upstream. U is for upstream, and D is for downstream. Another way to look at this is a sort of master-slave kind of relationship. U is the master, D is the slave. In other words, it means that the public interface, the contracts exposed by the U, the upstream context, those rules rule. They have the highest priority, and every other context that is dependent on that, that is downstream compared to that, has to comply with. Now, there are two different flavors of master-slave relationships. The difference is essentially in the margin, in the room for negotiation that you, as the architect, accord to the teams involved. You have to, in general, imagine that there is a team behind each of those blue boxes, behind each bounded context, okay? So let's say that at some point, the team responsible for the business logic, accounting, biz rules, payment, shipping, decides that they have to make some changes to their code that could possibly break dependencies built by other contexts on that code. So in this case, we have, for example, if I make a breaking change in the central module, for example, the front end, also the back office, could be potentially broken because they depend. So now, the slide shows that on the UD arrows connecting the business core with back office and front end, they have the label supplier. Customer supplier is one flavor of a master-slave relationship that says it is expected that there is some discussion between the teams. So me, the chief architect, creating this context map, I intended to state that whenever the core team responsible for the core business logic has potentially breaking changes, they must notify. They could expect to receive complaints or a different perspective from dependent teams, they are expected to consider those concerns, but the final word on the decision is to the U module. So discuss, but final word, in case we cannot reach an agreement, is on the U team. When you have instead a conformist relationship, it means that there is no room for negotiation at all, zero. And typically, you have a conformist relationship when you depend on legacy code, when you depend on an external gateway you don't control, or where you depend on such a highly critical piece of code that you, the architect, the chief architect, decides, okay, they do whatever they want, and everybody else has just to conform to their API. And finally, DD relationship is called partner, and it's 50-50. So the two connected blocks, bounded context, microservice, they are expected to ship together. So if there is any of those, of the two parts, that needs to have breaking changes, they have to come, the two teams have to come to an agreement. The context map is created by and countersigned by the chief architect. So this is your vision of how the system is devised and how the system has to be built by distinct teams at work on distinct vertical slices of functionality. And just for fun, this is a realistic context map. Okay? Sometimes it's pretty larger and more intricate than the other one for just demo purposes. So in the end, one bounded context equals one microservice. This kind of equation essentially is the value, is the final summary of this presentation. So now, in summary, I had a microservice architecture and I didn't know. Because, okay, say you are a startup, okay? You typically don't care about doing big upfront design. You just start doing things to get as many customers as possible. And this is the overall graph that in some way describes the microservice architecture that I had in mind when I prepared this talk. It's the representation of the backend system of a company that is active in professional sports and is involved with providing services for live scoring, for content in sport venues, primarily tennis, and needs to have dedicated applications, mobile, server, Flash also, to capture and have a handy capture and manage and manipulate data about players, tournaments, draws, schedules, things like that. This is the version we have today, but 6 years ago, it was a completely different thing. It was just a palm top compact iPack application, let's say a sort of mobile application, which was capturing, manually operated by a user, which player scored the point, and was transmitting the input to a server, which was an ASP. When I got into the project, it became an MVC, ASP.NET MVC application, an API server which was receiving the data, saving the data into a local database, and exposing a feed for a Flash application to receive and generate the videos, the animation, to be displayed on big screens. At some point, we figured out but we are now essentially, for every single match, we have to enter player information. Let's create a dedicated, separated player server that exposes a web service, okay, with the information per player by ID. And then we built something slightly bigger. So instead of just having a player server, let's create a true CMS system that involves tournaments, players, but also schedules, also draws, and many other things. We decided in first place, and the first step, to move the player information into the CMS server, but then to better distribute the traffic, we move it back to have a player information just linked to the CMS, but managed by a dedicated microservice. And then we decided to add a tournament server for specific dedicated services that just require to have a player info available. And after that, this is the final step, we built a comprehensive, larger management system that does many more, provides many more features like badging, hotel booking, and many other services around a public event. So we built this in about 6 years, one piece at a time. And the nice thing is that those black boxes that you see on the slide are independent ASP.NET MVC applications. And they can be replaced at the cost of rewriting it from scratch and changing the DNS so that the new application start receiving the same calls, and as long as the public interface doesn't break dependencies, it's fine. The next point we have, the next task on schedule is rewriting the player server, for example, because we have we have identified a few missing points, and we also need to give it some UI that it doesn't have at the moment to try to attract socials on this public, freely available service. So in the end, I believe I have built kind of ideal microservice architecture, and I didn't know, because I never started with the purpose of building the perfect or ideal or working microservice architecture. The reason why we ended up to something we can recognize as microservices the reasons have more to do with productivity than pure technical matters or technologies. We didn't want to be compatible with containers, support this or that. We just wanted to be productive and achieve our goals, our business goals, as soon as possible and as effectively as possible. In other words, the choice of going towards microservices in the end has to do more with common sense and attitude to solve concretely big and even especially small business problems than religion or design for scale. You're not Facebook. Nobody is here, I guess, is Facebook. We don't have, be honest, we don't have the problems, the scale problems of Facebook, Amazon, Netflix, and those big guys. We have to build applications in the most reasonable way, and microservices, because it splits a problem in smaller parts, is definitely an architecture to welcome. But it has to do, again, with common sense and not with this type of religion. This is a fake, of course, because there is no version of ReSharper that is expected to extract a microservice from every single variable. This is not because there was I remember a similar fake. Well, actually, it was not a fake. It was a real conference talk that I heard quite a few times. Every class is a service. And it was the slogan at the time that SOA, some 10 years ago, was all the rage. So I expect that every method is a microservice will never reach. Even though serverless Azure functions, makes me thinking of that probably every method could ever be a microservice one day. Okay, to finish off, just a few final pieces of wisdom, not from me. One comes from George Humphrey. Now, George Humphrey, even though his name is used to name this software law, George Humphrey, I think the name is George, is a scientist and he does psychology. So he has no involvement with software development, yet someone paraphrased his thoughts about psychology and adapted to software and said, the user of the software won't know what she wants until she sees the software. We usually smile at those things. We use this concept to create funny meme to share on the socials. But actually, this is exactly the point. The user of the software won't know what she wants until you show something, until the user, the company, the customer starts, whenever you show some prototype, you are giving users a new vision, a new perspective on the model that they can have, the processes. So it makes sense that you receive, the moment you show the first prototype, you receive a lot of feedback that could even change your own perspective of the architecture you created. So every architecture can only be evolutionary. And the lemma, one lemma to this law, the Wagner's lemma, an interactive system can never be fully specified, nor it can ever be fully tested. You have to stop at some point and accept that the software is deterministic, but the real world is sometimes non-deterministic. Thank you very much for your time.